Hi, I'm SMITA Desai. I'm going to explain question MOSFET as an amplifier. MOSFET as an amplifier. Amplifier is a circuit which amplifies the low level signal. So, generally, as an amplifier, transistor as an amplifier, we are using common emitter configuration. Like that, in MOSFET, we are going to use common source amplifier, CS amplifier. If source terminal is common, that amplifier is called as common source amplifier. Similarly, VGSQ is the positive DC gate to source voltage which is higher than VGS TH or VT. So VGSQ means input side voltage, which is positive DC gate to source voltage, that should be higher than threshold voltage, then only this amplifier will work. It biases the MOSFET in saturation region of its output characteristics. So when MOSFET is in saturation region, then only it operates as an amplifier. So circuit for this is drain resistor, so it is denoted with letter RD, and this is the symbol of MOSFET. This is source terminal, this is drain terminal, and this is gate terminal. Gate, drain and source terminal. Source, drain, gate terminal. Okay. To input gate terminal, we are giving VGSQ input. We are giving VI input. Okay, we are giving VI input, which is AC signal which we want to amplify, that is VI input voltage. And here we are applying some DC voltage VGSQ. Positive, negative. This is also positive, negative. This is MOSFET. RD is the drain resistor. This is coupling capacitor output, and this here we are taking output voltage. This is N channel and source is grounded, so this is a common source amplifier. This is N type enhancement MOSFET. Okay, input is VI, we have applied here, and here we are taking to the drain, we are taking output voltage. Okay, so this is a diagram of the N channel enhancement MOSFET. So in positive half cycle, what will happen? VGS changes sinusoidally above VGSQ. Means VGSQ is a DC given to this. Here we are applying VDD. VGSQ is DC voltage which is applied between gate and source. So VGS, which will flow due to this input given, that will flow above or below to this VGSQ. Hence, ID changes sinusoidally above and below to the IDQ. IDQ is the current which is flowing due to this VDD. VDD is a DC again source. VGSQ is again DC source. So due to VGSQ and VDD, there are some DC inputs and output voltages, input output currents are also available in this circuit. So as we apply AC signal here, then that AC signal will flow above or below that DC signal. So in positive half cycle, VGS changes sinusoidally above VGSQ, hence ID changes below and above IDQ, hence the voltage drop IDRD changes above its Q point. Whatever drop you will get here, that will change above and below IDRDQ. Means the drop which is due to this VDD, that is IDRDQ, but due to this AC signal we will get again some drop that is due to this AC signal, and that will flow above or below that IDQ. Hence VDS will change simultaneously below VDSQ, because VDS is drain to source voltage. VDS is equal to VDD minus IDRD. VDS is equal to this voltage is equal to VDD minus this slope, because in this branch we are having only 3 drops. Drop across RD, drop across this signal. We are having only 2 drops, and this is our source. So VDD is equal to this drop plus this drop. So this drop is nothing but this minus this. So VDS is equal to VDD minus ID RD. So thus we get the amplified but inverted version here, because VDS will become negative as ID increases. As ID increases and VDD constant, VDS will decrease. ID increases, VDS decreases. So for positive input, since input is positive, we are getting maximum ID, and since ID is maximum, VDS will be reduced. So for positive input, we are getting negative output. These are the waveforms. So first waveform is of input voltage. Second waveform is for drain current, ID, drain current. Third waveform is for voltage drop across RD, Fourth is VDS, drain to source voltage, VDS, and last one is output voltage V0. Now if you are not comfortable with wordings, you can write here input voltage, then drain current is ID, then this is ID RD drop, then this is VDS, and this is V0. Now it is easy to remember: input voltage, ID RD, VDS and V0. Okay, this is input voltage, this is output current, this is the drop across RD resistor, this is output voltage VDS or drop across MOSFET, and this is output voltage. Okay, now input, this is AC input which we want to amplify. Take the projections here. Okay, now what this is AC signal, but due to this VDD, we are having some DC ID here, and that will be denoted with letter IDQ. The current which is due to this VDD, that will be IDQ. Similarly, drop across this ID RD is ID RDQ. Okay, similarly VDS is drop across this due to this VDD is VDSQ. Okay, this much is drop, this is zero signal, this is zero signal, this is zero signal, means above zero, this much is DC level which is present as a ID drain current in the circuit. This is a drop across ID RD. This much DC is available without any AC input signal, and this much VDSQ is available in the across the MOSFET due to the DC signal. Now when we applied AC, now this due to this AC, again some AC drain current will flow, which will flow above and below this IDQ. Now got it? Again same, this voltage drop across RD will flow above and below this IDRQ or IDRDQ. Okay, now current, since VDS, we are having this equation as increases